All right, so welcome back. So the first thing we have to do in this is we have to design our models. So this is what we had you kind of like brainstorm about before, and now we're going to tell you the solution that I chose to use that we have to implement. To be honest, there are an infinite number of solutions. Some better, some worse, some about the same. The one I'm going to show you, I think, is pretty good. It's certainly not necessarily the best, but since the rest of the app uses it this way, you have to write the code exactly as we're going to do it together. So let's look at the data model that I chose to design. So I considered, should there be users? Should there be students? Should there be teams? Turns out that users, we do not actually need to save that because we don't save anything for the user. All we really need is we need a key to organize all the other keys in. And we can make a key without even making an entity. So we don't need a user. At teams, I'm going to actually not make an entity for team. It's just going to be one of the properties that's in a student. Assignments, we definitely need to make an assignment. It's going to belong to a user, so it's going to be in its parent key structure. It needs a name, but it does not need a last touch date time. Grade entities, we definitely need grade entities. It's going to be associated with an assignment, so its parent is going to be an assignment. And then that assignment is going to have an parent of the user, right? And so there's some clever things that we can also do. So I want assignments to be, so no student can have two grades on the same assignment. I want them to make sure that if you put something in, it blows away the old one, right? So I'm actually going to do some clever things with keys as well. I'm going to use a name for the identifier. It's going to be kind of clever. And it does not need a last touch date time. And the CSV files are really just temporary, right? So you send up a list of students, it uses them to make the student objects, or you ask for grades and it gives you grades, but there's nothing that needs to happen there. So that's kind of my plan, is I'm going to have these three. And if I was going to draw out my data model, this is kind of the way I've been drawing it. So I choose to draw the key structure because that's important. So this is kind of like my key side. And then this is my actual entities over here. So the way I'm going to keep track of who owns this thing is with a parent key. The parent key does not point to an entity, so there's no entity for it. And the kind doesn't really matter, so I'm just going to say the word entity. And then the identifier for it, I'm going to use a name key, and it's going to be whatever user is logged in. I'm going to use their email address. And I'm also going to convert it to lower just to make sure that there's no confusion with uppercase and lower cases in emails. I do that a lot, by the way. If I get an email, I convert it to lower, just a little safer. So that's going to be the parent of everything that builds up inside of it. There's going to be two things that are kind of at the top level. There's an assignment, and then there's a student. The assignment is going to use a random ID, so it's just going to get a numeric integer ID that's going to be randomly assigned. And the student, I'm going to do something kind of clever for him. I'm actually going to make his identifier be the row's username. So row's usernames are supposed to be unique. That's how the system works. And if I want to make another student, I don't want to accidentally, if I make a student and it's got the same row's username as somebody else, it's going to blow away that other student's information. So one of the clever things about this is I don't even have to write an insert method. If I use a clever identifier, it'll actually blow away the old one, which saves me trouble instead of making very careful inserts. So that's how I chose to set that up. And then a grade entity is a subclass of an assignment. I wanted to use kind of the same trick there. So I want only one grade entity in each assignment for each student. So I'm going to give it an identifier as well. So you can see this clever use of identifiers can save you trouble. And this clever use of a parent structure makes it to where you don't even have to save the user. If you look at the properties that are in each entity that I've chosen, student has ones you would expect. So last name, first name, row's username, and then the team is just a string property, nothing special about the team. The assignment, the only thing you actually have to save for it is its name, because it's associated with a user because it actually has that as a parent. The grade entity, it needs a score, so it has to have a score. And then it keeps a pointer for who it's for. So it's got a key property. Oops, it's got a pointer to two things, right? For who it's for, which is of kind student, and then it's also got a pointer to what assignment it's for. So that's a key property of type assignment. Some potential savings you could get in this is I chose to make it this way. This is how we're going to implement it. You can end the discussion there. But to be honest, there's a chance that you maybe didn't even need that row's username property because it actually is the ID. And there's a chance that you didn't even need this assignment key because that is the parent of this guy. Now, it turns out that you probably do want them because, to be honest, sometimes it's easier. So if I put these guys back, sometimes it's easier to like make queries and stuff if it's actually like a property, even if it's your identifier or something like that, because you can't do queries over the identifiers, well, at least not as easily. And I chose to make the assignment key both the parent and part of the entity itself, just for simplicity. It makes a lot of things easier. And to be honest, the goal is not to make this the most efficient model. It's to make one that works well and is easy to use. So this is the data model that we're going to be implementing. Let's go do it, and we're going to start with models.py. So coming into models.py, the first thing we've got is we know that we're going to have three classes. So we're going to have a class of type student. It's going to be an NDB model. Just so I can type them all, I'm going to say pass. And then after a student, we're going to have an assignment, and it's going to say pass as well. And then the last one is we're going to call it a grade entry. A lot of different names I could have chosen here. There's so many names. These are the ones that I picked, so these are what we've got to make them. Depending on how you're set up, it may have used 2 or 4 spaces. That's fine with me. It looks like in this environment I'm set up with 4, which is fine. It's recommended that whenever you're doing these things, you actually put in some type of doc string. But to be honest, this is so simple. I don't know. You could have been fine without it. So a student is going to need to have a first name, which is a NDB string property. He's going to need, so it's a bunch of strings, so I'm just going to copy them. He's going to need a last name. He's going to need a row's username. And then he's also going to need a team. And then completely optional for the team, I decided that if somebody gets put in without a default team, I would go ahead and write that their team was none. That way, if you wanted to make one without a team, I would put something there. To be honest, that's completely optional. I'm not even really sure why I chose to do it, but I did in the notes, so I'm going to do it here. Right? So that's the student. The assignment, and like in a real world, I'd be flipping back and forth between my design and then my implementation like quite a bit. But the assignment is going to only need one thing. It's going to need a name. So being lazy, I'm just going to copy from above and say assignment. And the assignment has a name of that assignment, which is a string. And it's kind of interesting. That's the only thing that's in its entity, because all the other relationships are taken care of in other ways, right? So the grade entity points to it. It has a parent, which user it's for. So it's really kind of interesting what a simple model it turned out to be. And then we're going to say score for a user or for a student on an assignment. So this one's kind of the most interesting. What it's going to need is it's going to need a score. So I'm going to say score right here. A score, just so it's a different thing, we're going to make it an integer property. To be honest, if I was making this app for usage, I probably wouldn't use integers because that limits professors to only enter integer grades. I might choose to make it a float so they could enter fractional things. I might also choose to just make it a string so they could enter like A, B, C, and then just figure up what type it is like on the client side. But for this example, keeping it simple, just an integer property. The next two things are kind of more interesting. So we're going to save a reference to the student via the key property. Key property, you could just write like that, but most people go ahead and specify what the kind is, right? So the kind here is student. And then we also need an assignment key, which is a key property. And the kind on that one is assignment. There are some limitations with the way that I've chosen to write this. So the way that I've chosen to write this code is I've actually put the class in here, like there's no weird quotes around or anything, and that works great. One limitation is the order actually is important in this. So in order to use this syntax, you have to say student, it's declared, it's fully defined, and then I use it below. But it's kind of weird for Java developers to care about this order, but it's one of the ways Python works. There are ways around it, but we're not worried about that right now. All right, so that's it for this time. We made our data models. You can see why we're doing more than just this, because it's really interesting once you start to use these data models. But we've got the models.py built to our data store model design. See you next time. Bye.